Hi everyone, it's Matthew Griffin and welcome to the second instalment of Can we use artificial intelligence as a one-on-one tutor for students of all ages and subjects of all things? Now, for those of you that have been following this little video blog, you'll know that my daughter, Pippa, has to skip a year at school. So she was year 3 in the UK's academic system. She's now moving up to year 5 for a variety of different reasons that we actually explain very clearly in one of the first videos. We aren't doing it lightly, but the upshot of all of this means that she's got to skip a year and she's actually got to make sure that she's got all of the knowledge that she needs so that she's not left behind. Now, the school that she attends has actually provided us with a copy of the Year 4 UK academic curriculum, and what we're going to do is we're picking our way through it. What we're going to do today is we're going to be seeing if we can actually use AI, in this case ChatGPT, to teach her all about electricity. So do you think we'll be able to do that, Pips?
Yeah.
Okay. Now, so stay with me. So what you can see on the screen is you can see us on the right and you can see ChatGPT 4, which is a 1.78 trillion parameter language model owned by the now $30 billion artificial intelligence company OpenAI. And the first time we were using ChatGPT for maths, basic maths, it was making quite a number of basic mistakes. So let's see how we get on with electricity. Now this is completely ad hoc, ad lib, and from scratch. So when we have a look at the UK curriculum for science, it says, working scientifically during years 3 and 4, pupils should be taught to use the following practical scientific methods, processes and skills through the teaching of the program of study content. And then what we have is we kind of have these breakdowns here. So for example, for electricity, it then says pupils should be taught to identify common appliances that run on electricity, construct simple series electrical circuits, etc., etc., identify whether or not a lamp will light in a simple series circuit, recognize that a switch opens and closes a circuit, and associate this with whether or not the lamp lights in a simple series circuit, and recognize some common conductors and insulators. So you're kind of getting the picture. So anyway, let's crack on. So what I'm going to do is in ChatGPT, I'm actually going to start typing acting as a teacher, teach a 9-year-old student about electricity. Okay, so these large language models work best when you know how to prompt them. And that's going to be one of the biggest challenges that we actually have when trying to close this year 4 gap. So we need to identify some common appliances that run on electricity. So create a quiz for that, okay? Right. Okay, so acting as a teacher, teach a 9-year-old student about electricity. We need to identify some common appliances that run on electricity, so create a quiz for that. Okay, so quiz. Can you identify which appliances run on electricity, Pips? So television, does a TV run on electricity?
Yes.
Okay, correct. A refrigerator?
No.
Oh, a refrigerator does.
Yes.
Oh. Does a bicycle run on electricity?
No.
It does. What about a microwave oven?
Yeah.
Yep. Books, do they run on electricity?
No.
Exactly, unless it's a Kindle maybe. What about the air conditioners? Do air conditioners run on
yeah.
electricity? Yes, you're right. Toaster?
Yeah.
Desk lamp?
Yeah.
Okay. Does a pencil run on electricity?
No.
Exactly. What about a computer?
Yes.
Like the one we're using now. Okay.
Yeah.
So, what we've managed to do is we created a little quiz and everything else. And if we had a little bit more time, we could start going into a little bit more depth on some of these things. Now what we're going to do is we're now going to talk about simple electrical circuits. Explain a simple electrical circuit.
Circuits.
I can't spell circuit. Circuit for a
9-year-old.
Yeah. Okay, so when we actually have a look at constructing a simple series electrical circuit, we can't really do the practical aspect here because we're obviously using an artificial intelligence that is shoved into a computer in a server farm somewhere. But what we can do is we can use ChatGPT to explain the concept of a simple electrical circuit. However, we can get it to do it in the style of a 9-year-old. So do you want to press return, Pips?
Yeah.
Okay. Okay. Now, bearing in mind that one of the benefits of using these artificial intelligences is if you're actually trying to teach your children some new things, as a parent, you might not actually understand some of these things yourselves. So this is where these AIs can actually act almost as an independent expert that you are able to tap into just in the same way that you would tap into a regular teacher, a regular expert, or even a regular paid-for tutor. Okay, so if you want to read that then, Pips. So, you want to read it out loud?
What part?
So, all the way from here, all the way down to the bottom.
Why?
Because you've got to learn about simple electrical circuits.
Fine.
Okay, so you can read out loud.
From all the way up there?
Yeah.
Fine. An electrical circuit is like a circle of a loop. The electricity needs to flow all the way around it to make the things work. It's like when you ride your bike around the neighborhood, starting and finishing at your house, sir. The path that you take is a circuit.
Just like in electricity.
Okay.
Okay.
Now there are a few important parts in an electrical circuit. 1. This is where the electricity comes from. It could be a battery or a solar panel or an outlet. Your house.
Or an outlet in your house.
It's like your house is in the bike, riding analogically.
It's like your house in the bike ride analogy, which is the description.
It's where the journey begins.
Yeah.
These
conductors.
2 conductors. These are usually wires that are electricity. Electricity travels along. They have to made out of materials. Let's electricity flow through it easily, like copper. This is like the path or ride your bike. Rode your bike on. 3. Load. This is the thing that uses electricity.
So think about each word, yeah. So this is the thing that uses
the electricity to do something useful, like a light bulb, a fan or television. This is like the park you visit during your bike ride. 4. Switch. This is a device that you can start on the electricity. Following
So this is a device that can start or stop the electricity flowing. So it's like an on-off switch for electricity.
Yeah. It's like a gate that can open or close the path
The path.
on your bike ride.
Yeah.
Let's put these parts together. A very simple
Circuit. Okay. No. So imagine you have a battery, the power source, a small light bulb, the load, and some wires, the conductors. First, you would connect one end of a wire to the positive side, usually the smaller side of the battery. Okay, so that's your power source. So you start with the power source. Next, you connect the end of the wire to the bottom part of the light bulb. Okay, so you've got two wires, one coming from one side of the battery, one coming from the other side of the battery, and then both wires connecting into the light bulb. You understand that?
Yeah.
Now, if you have a battery connected to a light bulb, what will the light bulb do? Will it be...
Turn on?
Yes, that's correct. Okay.
Because light bulb uses electricity and batteries do.
Yeah. Okay. So what you've
Because they charge things.
Sort of. Yes, I do. But in this case, we're using it to power the light bulb. So what we've just done is that is a circuit. So we've got a power source. We've got... What else have we got? What are the wires?
Controls.
Conductors. So the wires are conductors. And then what's the light bulb?
Switch.
No.
Load.
Yeah, load. Okay. So what we have is we've got the battery, which is the power source. We've got conductors, which are the wires, which conduct
then we've got
or transmit the electricity.
Then we've got
load, which is the light bulb, which is the thing that uses the electricity to do something. Now, how would we turn the light bulb on or off?
By using the switch.
Ah, okay. Right. And the switch is like a... What is it? What's it like? Do you remember? So read it again there.
It's a device that can start or stop the electricity flowing. Flowing.
Okay. So what is it like?
It is like a gate that can open or close a path, like you're on your bike ride.
Yeah.
Like
so if you wanted to open a gate on your bike ride, what would you have to do?
Light switch.
Well, you could push the gate. So you could push the gate open.
Yeah.
Now,
like pushing a light bulb.
Yeah. Now, when we want to turn these lights on or off, what do we press?
The switch.
Yes. And what's an example? Where are the switches in a house?
On the wall.
Exactly. Okay. Right. There we go.
There are wires in the wall.
So that is a basic electrical circuit. So what happens is these lights here are powered by what we call mains electricity, which is connected to a big power station. So it's a bit like a giant battery. What have we got? What are these lights connected to? What are the conductors?
Wires into the ceiling.
Exactly. So you've got wires into the ceiling. And where do you think the wires go? In order to turn it on and off, where do the wires have to go?
Switch.
Exactly, the switch on the wall.
So that goes like that,
okay.
Up through the ceiling, into your wall.
Yeah, exactly. So if we push the switch over there...
I go.
What happens? Well, yeah, you can. Go on then, go and push the switch over there. What do you think is going to happen to the light? It turns that one up and down. So this switch is...
Over here.
It's over there.
Over
That's the switch.
Over there.
Okay.
Over here.
I think it's that one. Yeah. No, other one. There you go. Yeah. Right, now let's not do that. So turn it back on again. Okay. So now what we've actually done is, Pips, have you learned what a basic electrical circuit is using artificial intelligence?
Yeah.
Okay, we haven't actually had to do any sort of particularly practical stuff.
Yeah.
And now what we can do is we can teach you about some conductors.
Yay. What are conductors?
Teach me about electrical
Conductors.
Act as a, we'll see if this works, act as a study buddy.
Study buddy. Study buddy.
Start from the beginning. Now ChatGPT can kind of figure out what I mean by the beginning. So I've done teach me about electrical conductors, act as a study buddy starting from the beginning, and talk in a style that a 9-year-old would understand. Okay, so press return then. Go on then.
Yay.
So let's see. So again, as I say, this is all ad lib, ad hoc, etc., etc. But you know, as we start sort of going through this process, we could naturally refine it and so on and so forth. Okay.
Can I read it?
You can, although it's now generating quite a long thing. So, so what we've done is ChatGPT's kind of created a long-ish essay saying, you know, when you play with your toy cars, they zoom across a smooth floor really well, but get stuck on the carpet. Electricity works a bit like that too. It likes to move along some things and not so much along others. So an electrical conductor is like a smooth floor for your toy cars. It's a material that lets electricity flow through it easily. And can you guess what the most common conductor is?
Electricity?
No, so the conductor are the wires. So do we know
Wires.
what are the wires? I mean, have you seen many wires recently? What are they kind of made out of?
Plastic.
Well, that's the coating, but inside them they have
Metal.
this. They do
Copper.
have metal. They've got copper.
Copper and metal.
Okay, now why would wires be made of copper and not concrete?
Because the heat might melt the...
No, it's to do with electricity. Do you think electricity would move through copper better than it would move through concrete?
Yeah.
Okay.
Because it's more smooth.
No, because it is a good
Electrical.
conductor.
Yeah.
Yeah? Okay, so it's a good electrical conductor. So now, give us some examples of good electrical conductors in the home. Should we do that? So press return.
Oh, you already did
Now we could do things like list format and etc., etc., etc. But here we are. What have we got? We've got, what's number one?
It's going up. It's going up.
What is going up? It's going, yep.
1. Copper wires.
Okay. What else is a good electrical conductor? Aluminium.
I have no idea how to say that.
Yeah.
Foil.
Yeah.
Metal
Utensils.
Coins. Iron and steel tools.
Yeah.
Metal jewellery.
Yeah.
Metal post and pans.
Pots and pans. Okay.
Pots and pans.
So, if these are good conductors, what does that really mean from an electricity point of view?
Conductors.
Yeah. So will electricity travel through these conductors easily, or will it find it difficult?
Probably difficult. Because when I was watching it, I bet today I had to load.
Load?
When I was watching it.
No, but that's the internet. That's something that's completely different. That's wireless comms, essentially.
Hard?
No, easy.
Easy.
Yeah.
I was going to say easy, but I don't know why.
Mm-hmm. So look.
It's smooth.
No, it's not because it's smooth. So now,
Explain what an electrical conductor is in 9-year-old
9-year-old terms.
In summary.
Okay, so here. Okay.
Okay, it's loaded.
So an electrical conductor is like the roads or paths that electricity uses to travel.
Yeah.
It's something normally made out of metal
Yeah.
because electricity can move easily through these materials. So what makes a good conductor?
Materials.
It's materials that allow electricity to easily flow through it.
Okay.
Yeah?
Okay.
So,
I read it.
yep, you can now read this.
Imagine you're playing a game of tag. You're it, and you're trying to catch your friends. If you're running on a smooth and clear path, you can run really fast and tag your friend easily. Right? That's what electricity does on a conductor. It runs smoothly and quickly.
Yeah. So what electricity is trying to find, should we say, are materials that it can travel through quickly. That's a good conductor.
Yeah.
If electricity can't move through the material quickly, then is it a good conductor or a bad conductor?
Bad.
Yes. Okay, so would we use wood, for example, in wires?
No.
No. Okay, would
It'll
we
burn.
use concrete?
Yeah. No.
No, that's correct. What about ceramic or tiles?
No.
No. What about aluminium foil?
No.
Well, you could.
Maybe in between the metal and something else.
Well,
Maybe in between that to keep it more steady.
well, you could use aluminium foil.
Okay.
Huh?
Yeah.
But what's the best one to use?
Metal.
Yeah, but which is the best metal? We discussed it.
Yeah.
Well, it's yeah. But
Wire metal.
wire metal? Yeah. Okay, but which one is that? It's reddish brown.
Copper.
Yeah, there you go. Okay, so cool. So, as you can see, what we've managed to do is we've managed to use AI to describe simple circuits. We've used AI to describe some of the components basically within simple circuits. So can you explain how a circuit works now?
You have to use copper.
Yeah.
You have to use conductors.
Yeah. So those are the wires. And then what do we connect the wires to?
Light switches.
Yep, so that can turn the lights on and off.
Yeah.
What else do we connect them to?
Lights.
Yep, or light bulbs. Yep,
Yeah.
that's correct. And then what else do we need? One of the most important things.
Electricity.
Well, we do, yep, which would come from, so that's a...
Would come from... I forgot.
Well, power station, battery, outlets, plugs on the walls, all that kind of stuff.
Pluggy.
So technically it's a power source.
Yeah.
So there we go. So very rough and ready. We're going to be honing this as we go. This is as much about me learning how to use AI as a tutor as Pippa learning how to actually use it as a tutor as well. And join us for the next session where we might be actually talking about sound or maybe some geography or history or art. Well, AI, we could use Midjourney for art, which we've done, haven't we?
Yeah.
Yeah, you created a flying pig, didn't you?
No, that's Caden.
Well,
He created a green flying pig.
okay, it was Caden using Midjourney to create a green flying
Yeah,
pig.
and I showed it to my teacher.
We did some unicorns, I think, then, didn't we?
Yeah.
But we can also use it for computing, design, and technology, and everything else. So take it easy. Let me know what you think in the comments. Let me know what we can improve, which is probably a lot, to be fair. And see you later. Take care.
Like and subscribe.
Okay.
Bye.
Bye. Bye. Bye. Bye.